So we're going to get into section 11.1, which is called the nature of probability. So typically I always ask everyone a little history of what you know about probability. So in the discussion of our discussion online, if you could make a discussion post, if possible, of maybe when you hear the word probability, what comes to your mind? Like, what's the first thing that you think about? And I'd like you to do that now. Like, pause this video and actually jump on there and do that, because that gives me a little indication of what you already have in terms of previous knowledge on probability, before I get into some definitional things in here in a moment. So, probability. So before we get into like the whole details of it, I would like to actually just talk about what an experiment is. So I know in science class, a lot of you think of an experiment as being maybe some kind of thing you do in a lab, all right, where there's a control or something like that. But an experiment in math, bear with me a moment while I get this rolling here. Okay, so sorry, an experiment is a controlled operation that yields a set of results. So you can see down below or on your notes that we're going to get into dice in a moment. So an experiment would be that we roll a die, right? We roll one die or multiple dice, and get outcomes from those dice as well. So that would be considered an experiment. The experiment we do is rolling the dice. The possible results of an experiment are referred to as the outcomes. So what is a possible outcome of rolling one die? Well, if it's a fair die and it's a six-sided die, our possible outcomes would be rolling a 1, a 2, a 3, a 4, a 5, or a 6. We then have what is called an event. An event is a subsection or a sub, not subsection. I'm mixed up my word I want to use here. Excuse me, let me restart that. An event is a sub collection of the outcomes of an experiment. So an event would be like, I rolled the dice twice, right? So then those would be maybe the sub collection of the outcomes. So maybe it was a 2 and a 3 and a 5 and a 4, right? That would be a sub collection of all the times in the experiment that I had rolled the dice. So there are actually two types of probabilities. Probability is, we're going to get a more formal formula for what a probability is, but in general, a probability is the chances of something occurring, right? So there are actually two types of probabilities we can have. The first type is called an experimental probability, but a lot of times we also call that an empirical probability. And what by definition is that? That is the relative frequency, which when we get into statistics, or if we've already done statistics at this point, we will examine that a little bit more. But relative frequency is a count of how much something occurs. So, oh my word, this is not working with me today. Okay, so relative frequency of occurrences of an event. How does it determine this empirical probability or this experimental probability? We actually do the experiment. So in other words, it's determined by actual observations. So we actually pick up a pair of dice and we roll them. And we do it a certain amount of times and we see what the outcomes are and we keep track of them. And then we say, okay, how many times did, let's say, the number 2 show up when I rolled it 5 times? Okay, maybe 2 showed up 3 times. So 3 out of 5 would be our probability. All right, that's called empirical or experimental. The other type of probability that there is called theoretical probability, sometimes referred to as mathematical probability, but in theory, what should happen if I roll a die? So if I have a 6-sided die and I roll it, how many times should I roll it in order for me to get a 5? Well, how many 5s are there on a die? There's only just one. So it should be that for 1 out of every 6 rolls, because there's 6 sides, I should get a 5. So this is determined through study, maybe a research, I would say, right? Through a study of possibilities, so of possible outcomes that can occur. I said Dan. I want that to be that can occur for the given experiment. So there is a formula, like I had mentioned. It's going to look a bit complicated at first, okay? So bear with me when I write this. Take a deep breath in, take a deep breath out, because it does look overwhelming, but it really breaks down to something very familiar, I hope, because many of you probably have seen probability before. So this P with a parentheses around a capital E stands for the probability of an event occurring, okay, which equals to the number, oops, hang on one second. It's going to equal to the number of times that the event E, and I should use a specific word here, which I don't know if it's going to work or not. Let's see. Has occurred. And this is actually a probability tends to be either a fraction or a decimal, which is kind of a chance. So it's a percentage or a probability, right? We're going to, in our class, list it as a fraction for now. And if we change it to a decimal, we'll talk about what we want to round it to and all that good stuff when we get there. So it's a fraction, and in the numerator, it's the number of times that the event E occurred. So for instance, I gave you a scenario about rolling a die and talking about the number 5. And I said the 5 showed up 3 times out of, let's say, I can't even remember. It was just 2 seconds ago and I forgot. So let's say it was out of 6 times, right? So the it was out of 5 times. Okay, so it was, say I rolled it and I rolled the die and there was 3 out of 5 times that it became a 5, right? So 3 would be the number of times that it occurred, and it goes in the numerator of a fraction. So here's the fraction bar. And in the denominator of our fraction is the total number of times the experiment got performed. So the total number of times the experiment has been performed. All right. Thanks for your patience with that. That's a little bit of writing for me to do on here. Okay. So we're going to do an example in a moment here. I have some digital dice here on the screen for us so that we can give this a try and actually conduct an experiment. I'm going to try my best to go back and forth between rolling the dice and also writing down what I get on the dice. So the example says that we want to roll this pair of dice, and we want to keep track and record what their sums are. And we want to do this 12 times. So that's going to get things, this is going to be kind of interesting here. Okay, so I want to roll the dice. So here we go. I'm going to roll these 2 dice and see what I get. So dice number 1, if I can get it, let's see. It might not be so kind to me, so hang tight for a moment. There we go. Roll the dice, and I'm getting a 1 and a 5. So I'm going to write that down. I'm going to write down 1 and 5, and we're going to add those together. All right, I'm going to roll it again. We're going to do this 12 times. So if you don't want to listen to me do this the whole time, you can kind of fast forward and just end up seeing what I end up getting if you want. I have 6 and 2, so 6 plus 2. I'm going to roll it again. I get 1 and 3. I'm going to roll it again. I get 4 and 4. I get 4 and 4 again. Probability, it's random, so that could happen, right? Let's hope it doesn't happen every time. That would mess things up. Oh, there's 4 and 6 this time. So I'm up to that. 6 and 6. And as we're doing this, I want you to think, what could the sums of these be? What are the possible sums that I can get with 2 dice? There's only certain numbers that I can get with having these numbers on 2 different dice. So I'm up here. I got 3, 6, 9. Okay, 10, 11, 12. So we got 3 more rolls to go. I have a 1 and a 6. 2 and 4. And 5 and 6. So let's think. So the smallest numbers that can show up on these dice would be a 1 and a 1, right? And 1 plus 1 is 2. So the smallest sum that I can get would be 2. I could get 6 and 6 as the largest 2 numbers on my dice. And 6 plus 6 is 12. So I have sums here that would range from 2 all the way up to 12. So let's see what actually happened here. Maybe I got 2 on here. I actually did not roll 2 ones, did I? So I did not get, there's some outcomes that could have happened that did not happen in our actual experiment here. So I got 5 plus 1 or 1 plus 5 is 6. 6 plus 2 is 8. 1 plus 3 is 4. 4 plus 4, which happened twice, is 8. 4 plus 6 is 10. I was just talking through. 6 plus 6 I just have right here. We just got 6 plus 6, and we did it off to the side just to talk about what the biggest sum of 2 numbers would be. But I actually did roll that, which is 12. 5 plus 4 is 9. 3 plus 3 is 6. 1 plus 6 is 7. 2 plus 4 is 6. And 5 plus 6 is 11. So, looking at this here, there are some numbers that occurred multiple times. There are some numbers that did not show up of possible numbers that I could get if I were to sum them together. So remember what our probability is. If I'm going to scroll up just a slight bit so that we could talk about it, we said that what is the possibility, the probability of an event happening. So what's the empirical or experimental probability of rolling a sum of 2? How many times did 2 occur in our experiment? Well, it looks right here that it never occurred. So we have 0 And how many times did we roll the dice? Well, we rolled it 12 times. So 0 out of 12 is our experimental or empirical probability. You could tell me, though, that that means that our answer here was 0, right? 0 divided by anything is just 0. Now, what does that mean? Well, in experimental probability, 0 means it never occurred, right? 1 would mean it always occurs. So probabilities are fractions and decimals, between 0 and 1. Over here, the next part of this question is asking how many times did 7 show up? So if we look carefully through our data set here, it looks like 7 showed up only 1 time. So our probability would be 1 out of 12, or 1/12. And there you have it. That's kind of an example to get us thinking about probability or chances of things occurring through empirical or experimental, where we actually did something in terms of practice, okay? So our next example, here it is. It says that, just kidding, here's our example. Our example says at the music store, 60 people were selected at random and asked to choose their favorite type of music. Of those 60 people, 12 chose rock, 16 chose country, 8 chose classical, 24 chose something other than those 3, rock, country, or classical. Let's determine the probability that the next person entering the store favors rock music. So we're doing this experimentally based on something that already occurred, right? The experiment already took place. We don't actually have to collect this data. We just go to use the information that we gathered. The study already happened. So in this question here, rock music, it says here that there were 12. And I'm going to write this in terms of our notation. So P parentheses rock. Okay. And then that was 12 out of 60. Now looking at 12 and 60, I can tell that those two numbers can be simplified because they both end in even numbers. So I definitely could divide by 2. 12 divided by 2 is 6, and 60 divided by 2 is 30. Now I can look at those and say, oh, those could be divided by 3. So I get 2 out of 10. And then one more time, I could divide by 2. Now, if you can catch and see what the least common, the greatest common factor is between the two numbers, you probably noticed that 6 would have worked, but also 12 goes into 60 evenly. So we want to simplify those fractions as much as possible, and it ends up simplifying to 1/5, which means that 1 out of every 5 people at that music store would favor rock music. On the other hand here, let's say we want to look and examine country music. We have the probability of country, which would be 16 out of 60. Now let's see, can we think about maybe what the biggest factor of both of these would be? Well, definitely 2. But if 2 works, I usually try to see if 4 works. Now, do you think 4 can divide into 16 and 60? Well, it does. So I can divide 16 by 4, which is 4. And I can divide 60 by 4, which would end up being 15. And that would be simplified as much as possible because the greatest common factor of 16 and 60 is 4. All right, what about all the others? So basically we need to determine how many did not choose rock, country, or classical, and did they tell us that in the question? And I think they did, right? They told us how many didn't pick those, and it looks like it said 24 chose something other than that, right? So the probability, now sometimes because of how many words there are, sometimes we just write it as P of E, like the probability of that event we're talking about. And the probability of that event would be 24 out of 60. And we just talked about how 4 would be a common factor. But I know that if I look at 24 and 60, I could divide both those numbers by 6. And 24 divided by 6 is 4. And 60 divided by 6 is 10. Remember, I keep trying to get you to ask yourselves the question, am I done yet, or can I keep going? In this case here, 4 and 10 are both even numbers, so I can keep going and simplify this even further and divide by 2, and I get 2/5. So 2 out of every 5 chose something other than rock country or classical. Don't forget to, since you're allowed to use your calculators on everything, that you could type the fraction 24 ABC 60 on your calculator, hit enter, and let the calculator simplify it for you. Before I let you try this practice question here, what I want to do is I want to backtrack just to the previous page for a quick second and go back down to the bottom. I didn't do that notation that I just talked about a bit. So this would be the probability of a 2. And then this one on the right here would be a probability of a 7 occurring. That's usually how we write the notation for that on there. Okay, so if you want to go back and put that on there, you can, or just moving forward, you want to just be conscious of putting them on them. Okay, so I'm going to read this question, then if you want to pause this video to try it, you're welcome to. It says that the following table shows the number of visitors who they're looking at traveling websites and the number of visitors who frequently visited those sites. So we got TripAdvisor, Yahoo Travel, Expedia, Travelocity, and Priceline. Assuming this trend continues, it says, I don't know if it's on your paper or not, but it didn't translate onto mine very well, I guess. It should say if a person chooses to visit only one of those websites, let's determine the probability of this happening, okay? So we're going to look at Priceline, Expedia, and TripAdvisor. Feel free to pause the video and try it. So I hope you had an opportunity to give it a shot. If we're doing it directly based on the numbers that were given up above, we're going to have some really, really large numbers, okay? I'll be honest. So P of E, the event of Priceline, I just don't want to write Priceline out right now, to be honest. Priceline, if we look up at this, is 15 million. So we have 15 million with 6 zeros at the end, right? Divided by, well, it gave us the grand total. That was very kind of this question to do that for us. 101,250,000, and there. So like I said, if we can simplify this, that would be great. Let's try that. Your calculator might not like how many zeros there are or how large these numbers are. But remember, we can simplify some of this if we wanted to. Like these 3 zeros can simplify right? And you could type in 15,000 over 101,250. You could even cross off another set of zeros if you want to have the calculator simplify it for you. As a fraction, this ends up becoming 4 over 27. So I wonder if you got that. I'm curious, okay? The other thing you can do, let's talk about what this would look like as a decimal, because when we get into some stuff regarding statistics, we look at things in terms of decimals. So as a decimal, this ends up being approximately, because we're kind of rounding it, to 0.1481. And that number is rounded to the nearest 10th, 100,000, 10,000th place, 4 decimal places. And when we do that in statistics unit, that's how far we would actually round it off to. Okay, we would do 4 decimal places come that time. Oh my goodness, I'm trying to get this back to green. It's not letting me do this. There we go. Okay. Expedia, the probability of the event of Expedia occurring is going to be 23 million over our grand total of 101,250,000. And same thing, if you want to cross off some zeros so you could put it on your calculator, simplify it as much as possible. I'm getting 92 over, so this ends up equaling 92 over 100, nope, not 100, 405. As a decimal, if we round off to 4 decimal value places, it's about 0.2272. And last but not least, TripAdvisor, that event that we're looking at last, is going to be 24,000. No, I keep saying 1,000. I apologize. It's 24 million, much larger than 24,000. 101,250,000. And then we want to simplify that. And if you happen to do it, remember that you tried this, so hopefully you got it. We're getting 32 over 135 equals 32 over 135. And then as a decimal approximation, that is about 0.2370. So let me just talk about those decimals for a moment. So 0.1481 for Priceline on Part A, that's about 14.8 or almost 15% of our visitors for the travel websites are going specifically to Priceline. 23% about, if I were to round, to Expedia, and about 24% to TripAdvisor. So very similar between Expedia and TripAdvisor. Okay, so there you have it. I hope you got those answers there. Hopefully you tried the challenge because it was quite a larger amount there. The law of large numbers. So this simulator here, if you go to the simulator and you type in like how many number of times you want to flip a coin, right? So this will digitally flip coins for you. If you just start off small with a small number, like between 4 and 10 or something like that, you might see that some cases that the percentage of heads and tails are going to differ very much, right? So if you keep increasing the number of trials, the law of large numbers says that the more trials you tend to do, the experimental, since we're doing this through experiment empirically, right, that tends to get closer to the theoretical probability. So if I flip a coin, what's the chance theoretically that I should get a head? Well, 1 out of 2, because there is 1 head out of 2 sides. But if I flip a coin, let's say 7 times, there's a chance, because it's by chance, that I might get 7 heads, or maybe I get 1 tail and 6 heads when I flip the coin. We never know, right? So the law of large numbers, which sometimes is referred to as Bernoulli's theorem, Jacob Bernoulli there, you can see the time frame where that mathematician was alive, came up with this concept that if we do things a large amount of times, the probability, the empirical experimental probability, gets closer and approaches the theoretical probability. So our next section I'm going to get into here is focusing specifically on theory. This first section was more on the experimental side of things. So you can see on our next slide here, our next part of our notes, that it actually looks very similar to what we already started off last class with. But remember that in theory, that equally likely outcomes is if each outcome of an experiment has the same chance of occurring as any other outcome. So in theory, or our mathematical probability, is that, remember, our probability of an event is the number of outcomes favorable to E. So we did kind of the formula earlier on the other page related to the experimental probability because it was talking about how many times it actually occurred. We did the experiment. But now we're just talking about how many times are in favor of something happening. Like I mentioned, heads on a coin, right? So there are heads and tails. The head, there's only one head out of two sides. So the favorable number of outcomes would be 1 out of 2, right? So the total number of possible outcomes is what we're going to divide by when we're looking at the theoretical probability. All right. So from now on in our textbook, our text will refer probability as this, okay? So they really kind of focus more on the theory moving forward as opposed to the experimental. So just keep that in mind. A couple quick facts, though, about probability. Number one, the probability of an event that cannot occur is 0. Probability of an event that must occur or always happens is certain would be 1. We got numbers that lie, like I had mentioned earlier, between 0 and 1. So they're fractions, decimals, whole numbers. Well, there's no whole numbers between 0 and 1. The sum of the probabilities of all possibilities. So if something is a probability of an event occurring, and then we add to it all of the others, the decimals all added together should equal 1. Which means if I solve this equation, and I subtract the probability of A from both sides, we get this, that the chances of something not occurring is 1 minus the chances of it occurring. So we call this the complement of the event, okay? So the probability of the event. So let's take a look at an example, and hopefully I can show you through the second part of this example what I mean by the complement. So we have a traffic light. A traffic light is red for 25 seconds. It is yellow for 5 seconds. It is green for 55 seconds. So let's see, how many total seconds are we actually talking about going through this cycle of different colors of our light? So we have 25 plus 5 plus 55. So 25, well, 5 plus 5 is 10. So 25 plus 5 is 30. 30 plus 55 is 85. So this is 85 seconds that's going through all three of those colors total. So it says, what is the probability when you reach the light that the light's going to be green? So sometimes we write the word out. I think we had mentioned that. So we can go P of green. Sometimes we just do a letter like G for green, R for red, Y for yellow. So the probability of green is going to be 55 seconds out of the total of 85 seconds. One more time on your calculators, you could type in 55 ABC 85, hit enter, and it will simplify it. So the probability is 11 out of 17. So I'm going to just keep these as fractions for now. So the next part is if it's not green, what colors can it be? It could be yellow or it could be red. So we use the 55. So yellow or red. For some reason, this board is not being cooperative quite today for me here. Okay, so 25 plus 5 is 30. So the probability, now let me show you a new notation too. Probability of green, but not green, we tend to use this little mark up above the G. which is also the same as if we put that little mark up above the P. That little dash indicates not green. So that what we're looking at is the probability of not the G, or not green. So we just said that it's 30 out of 85. And if I simplify that, I get 6 out of 17. And I could do that in my calculator. I could type that up, or I could just keep dividing. I could start with dividing by 5. And 5 times 6 is 30, and 85 divided by 5 is 17. So let me show you this thing called the complement, if I can get the color I want. Perfect. So here's the complement. Instead of doing the chances of it not being green, we could actually take 1 minus the probability of it being green, based on what we had said up here in the probability facts. So what was the probability of being green? Well, we just did that in part A up here. So this would be 1 minus 11/17. So to think back, what's 1 as a fraction, everyone? Well, with a denominator of 17, 1 would be 17 over 17. Minus 11 over 17, and 17 minus 11 is 6. So we get that same answer by doing this thing called the complement, by subtracting from 1 instead of having to count up, because sometimes there might be a lot of numbers that you have to add together. That's not what you want, right? So the quick way to do it is find the thing you want and then subtract it from 1, and then that'll give you the remaining of them. Okay, so there you have that. Cool. So we got one last page here to take a peek at for today. And there is a practice question they're all practice questions, so you might want to just pause the video and try to finish the last page. And then I'm gonna, in a moment here, just kind of go through everything and kind of wrap up the class for today in terms of our lesson. All right, welcome back. If you paused me and gave it a try, I hope it went well, and we'll find out in a moment here how that went for you. I hope so. I hope it was great. So here we have a dartboard, and you notice that there's 2 different colors on the dartboard. There's 26 partitions, as you can see, are shown here. It's a little hard maybe on my screen here to read those numbers. I think it's a little more clear if you look on your papers. They look pretty clear on mine. So it says that assuming that the dart cannot land in the black dot in the middle or on the outside, or on a border between those 2 colors, determine the probability that the dart lands in the specific section that is marked 15. So look carefully, see if you can find that section on your papers. And it's located kind of at the bottom right next to the 8 right here. Does everyone see that 15 right there? So that it says the area marked 15. So we're looking for the probability of a 15 being the spot where the dart lands. How many of those are there? Is there any other 15s on this board? Well, it said that there are 26 partitions, and it seems that all the numbers are kind of different. So the probability is that there's only 1 out of the 26 total. So our probability is 1 over 26. Now on my screen, it looks more salmon color than orange, right? It looks a little more pinkish color. On your printouts, they're obviously like shaded dark, shaded lighter. It's still lighter. It's the darker section, excuse me, on there. But it doesn't really matter because they're alternating colors. So out of 26, half of those are going to be orange. So the probability of orange is going to be 13 out of the 26. And like I'm saying in my words, half of them, that simplifies to 1 out of 2 anyways, or 1/2. All right, let's keep going with this here. The probability that we have, it says a number greater than or equal to 22. So you got to ask yourself the question, can it be 22? And the answer is yes. So how many numbers here are bigger than 22 and 22? So let's count. 22 is 23, 24, 25, and 26. If you were with me here on that when I did it, I'm counting 5. But how do we notate this? I say x is greater than or equal to 22. And I just counted 5 out of 26. And that can't be simplified. That's my answer. All right, so the last part is, what about areas marked with a number greater than 6 and a keyword here to combine this, and less than or equal to 9? So this side here means it can be 9. Greater than 6 means it can't be 6. So we have to have those two requirements. So I'm looking for two things. I'm looking for the probability that x is between 6 and 9, but it can be 9. So let's think about that for a second. Which numbers are between 6 and 9? 7, 8, 9. So we're looking for the probability of 7, 8, or 9. How many numbers is that? 3. So we are going to get 3 out of 26. Interesting. So can I simplify 3 out of 26? That's a good question. I should probably check to do that because I'd like to simplify my answers if possible, and I didn't do that. No, that's it. That's 3 out of 26 is our answer for that part of the question. All right, one more thing, one more question to wrap it up here. So it says the following chart contains information about a shopping cart full of jars of taco sauce. Here are all the different jars. It says, let's assume that they're about the same size and shape. That way, I know that actually some of these aren't, but we were going to pretend they are, right? So if these are all showing up at that stock clerk stocking up the shelf, and the clerk that's stocking the shelves picks one jar at random, and to put on the shelf, what's the probability that it's being selected A for Ortega? So the two pieces of this that we want to keep in mind are looking at the, give me one more second here. I'm trying to get a different color. Actually, let's change it up completely. Let's do something like pink. All right, so what I'm saying is like, what is the probability that we're selecting Ortega, right? Or P of O if you wanted to, okay? The probability of Ortega, if we look, is going to have a total of 10 jars within 42 jars. So 10 out of 42 actually simplifies to 5 out of 21. We can divide those two numbers in half. Use your calculator in the ABC button if you want. You can on there. All right, let's look at this one here. Ooh, it's changing it up a bit more than I want to. Here we go. Okay. Let's go with Old El Paso. So Old El Paso, looking at our table here, the probability of Old El Paso. We'll go to how many there are. There are 11 out of the 42. And fortunately or unfortunately, depending on how you look at it, you don't simplify that at all. That can't be simplified. All right, next it gets into more specific in terms of the type of, so mild, medium, or hot spiciness to your taco sauce here that we're looking at. In terms of this here, it's looking for Taco Bell's medium. So in this chart, we go to Taco Bell, we go to medium, and I'm seeing that there are 8 medium Taco Bell. So the probability of Taco Bell medium is equal to 8 out of 42. I can simplify that. That does simplify to 4 out of 21. any type of mild sauce. So this one here, it doesn't even really care that if it's a certain brand. It's just talking mild sauce here. So now I'm looking at the column of mild, and I'm going to the bottom here for how many total. And it's interesting is that the probability of picking a mild taco sauce is the same as the probability of picking the Old El Paso sauce, which is interesting to me that that occurs like that. All right, we're looking at hot sauce, hot taco sauce. So I'm looking at this column here, hot, going down to the bottom, there's 10. So I have less of a chance of getting the hot than I am with the mild. So it's equal to 10 out of 42. That can be simplified though. For every 21 bottles, 5 of them should be selected as hot taco sauce. And last but not least, we have Old El Paso and hot taco sauce. So it's got to be both Old El Paso hot taco sauce specific. And to get that, so we're looking at Old El Paso, excuse me, here it is here. I'm not sure why it keeps changing my color. Old El Paso. And we're looking at hot. So we're going across this row and down this column to find out that there are 2. Probability for this is 2 out of our total of 42, which can be simplified to 1 out of 21. And there you have it. That wraps it up. I'm curious, let me know maybe next time we see each other how that went, okay? So I will have the homework sheet updated for this assignment. What I can do is to, in our plan, put down what the assignment questions are going to be for this. And remember, I don't collect it. It's going to show up on one of those homework assessments for this section, and I'll give you a heads up on when that'll be as well too. Okay, so don't forget, check the homework sheet. See if there's any new assignments popping up as you are getting closer to the actual date of the 18th when this is going to be the class that you're doing this alternative plan for. So have a great day, have a great weekend actually, and we'll catch you at our next class.